finish up this question and just do one more, okay, to really stretch ourselves, okay, in applying quadratic inequalities to different contexts. I'm starting already. Right. Okay, so for question 4, yesterday we were looking at part 1. Okay, just to revisit the question, it said that the height of an object above the ground at time t seconds after it has been launched follows this quadratic function over here. Okay, so we're looking at something being launched following this function. Then in part I, yesterday we did part I. It said find a range of values of t for which the height of the object above the ground exceeds 384 meters. So yesterday we looked at solving this inequality problem. Right? That was what we did yesterday. Okay. So I will not continue with part I. We will look at part 2. Question asks, explain whether the object can reach 1,000 meters above the ground. Okay, so we want to know whether in this motion itself, will it reach 1,000 meters? Okay, there are several ways to go about doing this. One way is to look at when h is equals to 1,000. Okay, how does this equation end up becoming? Okay, so what's the solution like for this equation itself? Okay, so because we're just trying to determine whether it can reach 1,000 meters or not. Okay, in other words, if there is an intersection between the line y equals to 1,000 and the projectile motion, okay, that will mean that the object can reach 1,000 meters. So that is one option, okay, whereby there is an intersection. Right? Of course, the intersection can also be at the maximum point only, okay, or if it doesn't reach at all, okay, your y equals to 1,000, okay, will be not even intersecting the entire curve itself. Okay, so what we're trying to investigate in part 2 is about whether there's any intersection between the line y equals to 1,000 and the curve. Okay, so we don't need to go and determine whether there are what are the solutions. Okay, we just need to determine whether there are any solutions. Okay, so we can just simply look at the discriminant. Okay, I just brought this to the right side, and then I've kept the negative 16t squared, and that simplifies to negative 952. Right? So because we're just determining whether there's any intersection, it really doesn't affect us whether we solve it or not. Okay, so we can just simply look at the discriminant. And that gives us b squared minus 4ac which gives us a negative value of negative 35,328. So because the discriminant is less than 0, we can say that there is no intersection between the line y equals to 1,000 and also the curve, and hence it is not possible for the object to reach 1,000 meters above the ground. There's this. Okay, so that's one way. What is an alternative method? Okay. An alternative method would be to do completing the square. Then after that we look for the value of the maximum. Okay. Because we know that this will be a maximum curve since the coefficient of t squared is negative. Okay, so if I do my completing a square, being able to help us find the maximum value, I can then compare the maximum value, which is the height by the way, okay, comparing the maximum value with 1000 meters, then I can justify. Okay, so alternative, which is to compare maximum height of object with 1000 meters. So doing the completing the square itself, we will get this, and then we see that the maximum height will be 448. Okay, which is less than 1000 meters. Right? Therefore, the object cannot reach. Okay, so I've given you two options of solving, really dependent on yourself in terms of what you think about when you encounter a question. Okay. In fact, finding the maximum via this method is just one way. Next year when we do our calculus, when we do differentiation, we will have even more ways to go about finding maximum. Okay. Questions? Before we move on. Okay, this is the last question I want to cover in quadratic inequalities. Okay, let's read the question. It says that, okay, it's in your textbook page 45, exercise 2.3, question 6. So it says that John is building a rectangular pool. These are the criteria, okay, that he has set for the pool. Okay, the area of the pool should not be more than 54 meters square. There's a criteria for the length such that it should be 3 meters longer than twice its width, and also the width of the pool should be at least 2 meters. Okay, what is the possible range of the width of the pool? Right? So a lot of conditions given to us and not a single variable. Okay, no x has been defined. Okay, so from step 1 all the way to now, okay, we have learned algebra already, right? Okay, we have learned how to define x, okay, to be something. Right, so in this particular question, okay, what will you let x be? Be length. Do we agree with Roman? To let x be length, be width, right? Okay, I think that's a very natural thing for us to do. We always look at the end point of our question. Okay, what is it that we want to find? Since we're trying to look for the width, okay, we naturally will let x be the width of the pool. Okay, so let's try to maybe draw an image to understand the question. Okay, so we are looking at a rectangular pool. We have already let the width be x. Okay, the question says the area of the pool should not be more than 54 meters squared. Okay, how can I translate this statement into an inequality? Okay, area versus 54 meters squared. What is the inequality that we should use in between here? Less than or less than equals to? Should it be this one? Or should it be less than or equals to? Okay, so it should be less than or equals to, right? Because it says should not be more than. Okay, so the opposite of more than, yes, it is less than, but we must also include the 54 meters squared. Okay, so therefore, it must be less than or equals to. Okay, so we form this inequality just by looking at the first sentence. Then in the second sentence, it says the length of the pole should be 3 meters longer than twice its width. Okay, so twice its width, we know it is 2x. Okay, then the length should be 3 meters longer. So 2x plus 3 will be the length. Right? So we're using bits and pieces of the information to form and gather our information first. Okay, then after that, the question also said that the width of the pole should be at least 2 meters. That means that there is a lower boundary for our width. Okay, x itself, what is the inequality for 2 meters? Should this be less than? Okay, more than or equals to 1? Okay, because at least. Alright, so these 3 statements, we generate these 3 information in mathematics statements. Okay. Now, area itself, we only wrote the word area. We did not quite put in any variables into it. Since it is a rectangle, and since the length, we know that it is 2x plus 3, we know that the area can be expressed as x times 2x plus 3. Alright? So therefore, I can form x times 2x plus 3 to be less than or equals to 54. And this is how we can form our quadratic inequality to solve this question. Okay? Alright, then after that, continuing from here, it wouldn't be difficult for us to solve because we have that skill already. We need to first expand it because over here cannot be 54. Okay, then after that we bring the 54 over to the left. So we get 2x squared plus 3x minus 54. For which we can factorize this, where we get 2x minus 9, x plus 6. Okay, and then we rely on our graph. Must be a happy face because coefficient of x squared is positive, and then we get a negative 6 here and a 9 over 2 over here. Okay. Being less than or equals to 0, we're looking at this interval because that is where the graph is below the x-axis. Okay, so therefore our range of values of x will be negative 6 to 9 over 2, which is 4.5. You want to write 9 over 2, not a problem. And then we leave this as our answer. Is that right? Why is it not right? We're trying to find a b. Cannot be negative. Okay, so does that mean that, oh, then I change it to 0? No,
it must be bigger.
So we have forgotten, maybe we missed out on this piece of information. So we must keep in mind that x must be greater than or equals to 2. Okay, so it cannot just be negative 6 to 4.5. This is the answer to this. But to this entire context of the question, the correct answer for the range of values of the width will be 2 meters up to 4.5 meters only. Okay? Questions? Okay, we move on. Okay. Okay, we'll cover the last part of our chapter 1 and chapter 2 topic, okay, which is to apply what we have all learned into our real world context. Okay, so looking back at chapter 1.3, write the header here, applications of quadratic functions. Okay. I'm a little bit lazy to write the question today, so that's why I put up the PowerPoint slides. Okay, yes, chapter 1.3. Okay, we'll just be looking at 3 examples. Okay, so try 11. So, try 11, right? Okay, looking at your textbook, page 16. It says that a projectile was launched. I hope you know what's a projectile. Simply just a motion like that. Okay, from a catapult to smash a defense structure on a fort. Yes. Okay, its height, h meters above the ground, is given by this. So this entire motion that we have, okay, maybe I'll draw it here. Okay, is being modeled by these equations. Okay, and then it says that x and h are being defined a certain way. H is the distance above the ground, it is height above the ground. X is the horizontal distance from the catapult. Okay, so if we want to draw it out, okay, maybe the catapult is at a distance here like that. Okay, then x meters in this manner, in this direction. And then after that, the ground will be here. Okay, and then upwards direction will be your height. Sorry, it might not look very well drawn. Okay, so in part I, we want to find the height of the projectile when it just left the catapult. Okay, so how do we find the height h when it just left the catapult? Y-intercept. Why is it that we're looking at the y-intercept? Because it's the starting point, and at the starting point, your distance away from the launch position is actually going to be 0. Okay, so x is equals to 0. Right, so we're looking at when x equals to 0, everything actually becomes
进大连戏曲汇演，那么我们也欢迎有兴趣。
好。阿姨走，新年快乐。
So, height will then be equals to 3, right? Okay. Sorry, that really gave me a fright. I need to count my nose. Yes. Because your x is here, what? 0, then 0, 0, then just 3. That's your y-intercept. Okay. So let's look at part 2. We want to find the greatest height of the projectile after it was launched from the catapult, which means that we're looking for the maximum height, okay, the maximum point. Okay, so how can we do that? How to do that? Find maximum. Hello? Complete the square, okay? Now let's put that to a test, okay? So can you please complete the square for this one? Thursday you all tested on completing the square, right? So? Okay, can you please complete the square for this one? No, you cannot just times 2,500 because down here is an inch. It's not a value. Okay, so complete the square for this. Give you 2 minutes, shouldn't take too long to complete the square.
Assalamualaikum salam.
Wait. Yeah? How do I get what? 200, not 200 what? 2 over 25 divided by 1 over 2,500. So I factorize out negative 2,000 1 over 2,500.
I'm confused. Thank you.
How do we plot common factor? I take 2 over 25 divided by 1 over 2,500, right? Yeah? Can we get this? No point just copying, okay, make sure. I take this number divided by this because factorizing means I'm dividing one, right? Okay. So 3 divided by this, I'll get the 7,500. Yes. Oh, sorry, minus. Other than that, we are No. Okay, because this is a h over here. Okay, it is a function. You cannot just multiply then go where? Okay. No. Yeah, it's not a correct process of completing a square. Okay. Yes, question? Didn't. Factorize out this negative only without the 1 over 2500. You cannot do completing the square one. What is the completing the square method? Your x square must have coefficient of 1. And that is a problem which I saw in your EMATS WA. I don't know why, okay, I still to solve a quadratic equation. You don't do completing the square for what then? Now, use formula one. As long as I can move on this fast, then I may consider whether I can return the papers to you. If I can finish out 3 questions fast, so can get it. Careful and treat you very well. Part 3. Okay, part 3. And start. If the defense structure is 150 meters horizontal from the catapult, okay, so just like I did diagram, I extend it up in the race away. Okay, I don't know how to pronounce it. Okay, that's why I teach maths. So catapult is it? Okay, right. And 5 meters above the ground. Okay, so the defense structure, okay, we take it as a point. Okay, I don't know where is it. 150 meters away. Okay, and then 5 meters above the ground. So let's say this is the ground. This distance here is taken to be 5 meters. Okay, so this is the defense structure. Let me indicate it for you. Right, we want to determine whether this projectile will be able to hit it. Okay, to hit it means it must exactly hit that point. Okay, that is the assumption we're taking. That the defense structure is not a whole piece of item, it is a point itself. Okay, so what we will do to determine whether it can hit it or not, we can let x to be equals to 150 meters. Okay, according to this projectile. Then after that, I see what is the height. So when x is equals to 150 meters, I check what is the height value against this 5 meters. Okay, so substituting it into the function. Okay, and we see that it is equals to 6 meters. Okay, and 6 meters is above the 5 meters. Okay, so away from the defense structure. So therefore it is not possible. Okay? Yes. Yeah, you can look at it. But I need the conclusion. Because the question asks whether it is special. Okay, it's important for us to have this conclusion because the question asks whether will the projectile actually smash the structure or not. Okay, so make sure you answer the question. Right? Next. Try 12. Hey, can I erase this already? Alright, try 12. Okay, dash carefully over your eyes and stay self straight. quadratic function with its graph shown. Okay, so they were very kind to give you a diagram to help you understand the question. This entire thing is supposed to model an arc that is a tunnel, so it goes through this thing. Okay, so in this model, x meters is the horizontal distance from one end of the tunnel. So they have illustrated it here. This is one end. They measure the distance, horizontal distance in this manner. And then y meters is the height of the tunnel from the bottom. Okay, so this is the ground level, this is the height. The tunnel is 10 meters wide at its base and 5 meters high in the middle. So 10 meters wide, 5 meters high. They did not give you the model, okay, the equation that models after this tunnel. In fact, they want you to form it, Moses, I'm here. Okay, write the quadratic function in the form of this, okay, to represent the opening of the tunnel. So the problem here is, how can I make use of this information that we have to form the equation? Okay, so in this equation itself, we must first understand what is it that we want to find. I need to determine what are my A, P, and Q values. I'm not trying to determine my X and Y values, because my X and Y's, they are variables, okay, according to this entire thing. Okay, so I want to find the A, P, and Q. Alright? P and Q itself, okay, could be determined based on the x-intercept. Because when y is equals to 0, we are looking at this to be equals to 0 and this to be equals to 0. Such that x is equals to P and x equals to Q. So we are referring to the x-intercepts over here. Do we know what are the x-intercepts? Okay, we just read, right? 0 and then 10. Okay? So one of them is 0, the other one is 10. It doesn't matter which one is 0, which one is 10. Okay, but of course I can simply write it as this. We do not need to write it intentionally as x minus 0. Okay? Then the problem here is, how do I know what is A? Okay, what is the information that I have not yet used? It's 5 meters, right? Okay? 5 meters, what is the coordinates of this point? 5, right? This 5 is due to the height being 5 meters. This 5 is because 10 meters divided by 2. Our quadratic function is symmetrical. Okay, so this 5 over here is because we take 10 and divide by 2. Okay, so therefore, using that information, we substitute inside here at the point 5, 5, when y is equals to 5 and x is equals to 5, I will then be able to solve for the value of A. Okay, and that will be equals to negative 1 over 5. Yep.
How do we know the other x
This one. How do we know? Because this one is a quadratic function, it is symmetrical. That means right in the center, 10 meters divided by 2. If this whole thing 8 meters, then divide by 2, now it will be 4. It's a quadratic function.
So you want to find
The right in the center, your turning point must be in the center, along your line of symmetry. Quadratic functions are symmetrical, right? Correct? If down here, this whole thing is 10 meters, cut into half, okay, how long is this thing? 5, and then down here, 5. So, with my x-axis in place, 0 is here, down here will be 5, and down here 10. So that's why your x-coordinate must be 5. Because this equation is to model this entire quadratic curve. This whole red line is this equation.
So that 5 is the turning point.
Correct.
But why do we need the turning point inside?
Because I need to find A one. How else can we find A? Let's all be patient. I know everyone wants to eat up A. So let's attention. Okay. I think Jaden also feeling very frustrated. equation, y equals to negative 1 over 5 x times x minus 10. So this is the equation. So when x is equals to 2, we find the height. Okay, and that will give us, what's the answer? 3.2, right? Okay. Okay, part 3. Another point on the opening of the tunnel is 4.2 meters vertically from the base. That means from the base itself, bring over here, 4.2 meters high. Okay, we want to know what is the width of the tunnel at this point. Okay, so we're looking at this. Hang on, width. Sorry, okay. No. The question is asking, sorry, my bad. Okay. Vertically, 4.2 meters vertically from the base. We know that there are 2 points that will give us 4.2 meters. Alright? Okay, the question is asking for the width of the tunnel. In other words, they are looking for this. Okay? So, first we must know what is the x-coordinate over here and what is the x-coordinate over here. And then we will take the difference of the bigger one minus the smaller one. Okay? So, what we will do is, when the y is equals to 4.2 meters, we solve it to find out what is the corresponding x value. Yes, of course. Oh, I thought as in exam as in O-level, yes, but then WA no. Okay, and we find that the values of x will be x equals to 3 and 7. Okay, but we're trying to find the width, and that will be 7 minus 3, so 4 meters. Okay? Done? Last one. Okay, I'm just going to look at example 13. I'm not going to do the try question. It's similar to this one. The reason why I'm not doing a try question because I think the numbers don't help to bring out certain understanding. Okay, I think the example is better. Alright? So example 13, it says that there's an arc underpass that has the shape of a parabola. A parabola is something of this shape. Okay, there are many kinds of parabola. Okay, you can just see as understand it as this shape. Okay, a quadratic shape. Okay? Parabola, yeah. No, it's no longer in your syllabus to learn what are parabolas. Okay? Parabola, you can just understand it as this particular shape that we have here. Okay? So in the diagram, x meters is the horizontal distance from one end of the arc, and y meters is the height of the arc itself. Okay? There is a road that passes through, okay, under the arc, which is 6 meters wide, and the maximum height of the arc is 5 meters. Okay, we want to write down a quadratic function, in this case to be of the form y equals to a times x minus h squared plus k. I'm sorry if the question is a bit too low, okay, but you can refer to your textbook on page 18. Okay, so we want to find out what is the value of A, H, and K. In this particular case, different from what we did earlier on, this is a completed square form. This is a factorized form. Okay, in the factorized form, determining the x-intercept will be helpful for us to know what is P and Q. But now that we have the completed square form, okay, completed square form helps to tell us about the turning point. Right? So I can know what is the value of H and K if I know what's the coordinates of the turning point, which is the maximum point here. So what's the coordinates? It will be 3, 5. X coordinate is 3, Y coordinate is 5. Okay? So in other words, my H is 3, K is 5. Right? Based on the information alone itself. Okay? Then we need to find out the value of A. How to find the value of A? Okay? Several ways to do it. I find that the easiest is that this curve itself, the starting is at 0, 0, the origin. Which means x equals to 0, y equals to 0. So I can just choose the very simple one of considering the point 0, 0. Okay, and then I'll have 9a plus 5. So 9a equals to -5. And a equals to -5 over 9. And therefore, this will be the function that represents the arc. Okay? Yeah. No, it's not WA1. If it's in WA1, yeah, quite, gave me right, because now that I teach you all one semester for WA1. Okay? So WA1 is just your 2.1, 1.1, 1.1. Okay? So part 2, I don't want to go through part 2 because actually part 2 is being used in part 3. Right? And I think part 2 is a little bit strangely phrased. Okay? Because it says find the height of the arc when its width is 4 meters. The it over here, I don't know what does it refer to because the arc itself, okay, the width is fixed at 6 meters. So I think this part 2 is a bit badly phrased. I'll jump into part 3, okay? Because actually part 2 was designed to help you answer part 3. Right? So in part 3 it says, decide whether it is possible for a truck that is 4 meters wide and 2.5 meters tall to navigate through the underpass. So we are looking at the tunnel looking like that. Okay? Now I know that you all are not capable of driving. Okay? But I think we have all sat in at least a bus before. Okay? When you drive a bus through, okay, this is a one-way road. Okay, you drive through in the center of the thing. You don't lean onto one side to drive through, right? Okay, you drive through one road. You drive right in the center like that. Okay, and we imagine the truck in this case to be rectangular in shape, right? Yes. This one, the question says a one-way street. One-way street. Okay, no left lane, no right lane. One way. Okay, so we're looking at a 4 meters wide truck and 2.5 meters tall truck. Okay, we want to know whether is it possible. Okay, to know whether is it possible or not, it must be able to fit. Okay, so we know that your whole tunnel itself, the width is fixed at 6 meters, right? Okay, so if the truck is going to be 4 meters over here, that means that this distance and this distance over here, what will it be? It will be 1 and 1, right? Because 1 plus 4 plus 1 then will give us 6 meters. And we're driving the truck through right the center of the tunnel. Okay, so we can find out when x is equals to 1, okay, what is the height over here? When x equals to 1. If the height over here is lower than 2.5 meters, can the truck go through? Cannot. Okay, so that is your justifier. Right? So when x equals to 1, okay, your y value will be found to be equals to 2 and 7 over 9. Okay? And 7 over 9 is actually a recurring decimal of 2.7. Recurring. Okay? So because this is greater than 2.5 meters, so therefore we can conclude that the truck is able to navigate through. Okay?
Can you express the thing as 2.7 meter long?
No need, I just write it like this way so that I can